25 factorial is 25 times 24 times 23 times 2 times 22 times 21 times all the numbers below. 23 factorial is 23 times 22 times 21 times 20 and times all the numbers below, right? So if we have 25 factorial over 23 factorial, everything from 23 down will cancel. Does that make sense? So you're just left with 25 times 24. Do not subtract. It's not an exponent. It's not like you can say this is 2 factorial. It's not. Yes?
Can you have a factorial with a decimal?
No. I have no idea.
I don't know, that's what I'm asking.
Yeah.
I don't remember us talking about that.
Alright, so n plus 2 factorial, very similar to 25 over 23. This is n plus 2 over n. N plus 2 factorial would be n plus 2 times n plus 1 times n minus 1 times n minus 2 and so forth, right? N would be n times n minus 1 times n minus 2 and so forth. So, what happens is everything from n down cancels. And you're left with n plus 2 times n plus 1. I want you guys to take a second so you can figure out the 2n plus 2 over 2n factorial.
His price, he came up on his calculator.
Yeah, I typed in 5.5 factorial.
Wow, I thought you were going to
number.
Alright, I'm figuring.
Is it 5.5 times 5 times 4, or does it go down by ones or by?
It gives some crazy.
I tried going down by ones, like 5.5 times 5 or
Times
4.5,
yeah.
but it didn't give me the same, so.
What's the answer?
287.8857.
Is that 120 times 5.5?
Let me try.
This,
No, that's not.
No.
this might make sense if I
Yes.
understand what it means, because I don't recognize it.
I think it might just be like
That is what
calculator's algorithm.
It's annoying factorial decimal. I said it.
Oh, no.
Huh. I don't know what that last symbol is.
Yeah,
Big
I know.
R thing.
Yeah.
I'll have to look and see.
I don't get how that.
Okay. Alright, so 2n plus 2 factorial is 2n plus 2 times 2n plus 1 times 2n times 2n minus 1 and so forth all the way down. So this one just equals 2n plus 2 times 2n plus 1. Factorials are fun to play with. They don't come up a ton, but they come up some over the next several weeks. So just keep this in mind. This unit that we are about to start on is called infinite series. Although today we are doing sequences, we'll get into that in a second. But we only have one section of sequences and 9 sections of series. So it's overwhelmingly a discussion of series, not sequences. Alright. Today we are doing 9.1a, which is sequences. So at the end of this lesson, you will be able to write the terms of a sequence, find the limit of a sequence, and determine if a sequence converges or diverges. Those are the words of the chapter. In a nutshell, this chapter is about convergence. Right? Series convergence. But today we're talking about sequence convergence. What is a sequence? A sequence is a function where the domain is the set of positive integers. So your input starts with 1, then 2, then 3, and so forth. So the numbers that you plug into the function are only positive integers. So and then a sub n is the rule, it's the rule for the sequence. And it denotes the nth term. So for example, if you have the sequence 2, 4, 6, 8, 10, so forth, a sub 1 means the first term is 2. So the way we would read this is we say the first term is 2. The second term is 4. The third term is 6. The subscripts tell you which term you're talking about. Okay? And then in general, a sub n equals 2n. This is called the rule for the sequence. It's almost exactly the same as if you had f of x equals 2x, right? The only difference between f of x equals 2x and a sub n equals 2n is that a sub n denotes it's a sequence, which means the input can only be integers. Whereas f of x, you can have any input you want. All right, so do you all understand subscript notation, how that works? All right, a sequence is said to be explicitly defined if the input is an n value. What that means is, say I want the 30th term, I plug a 30 in, the answer is 60. I know that the 30th term is 60. I can plug in the term number and get out what it would be. That's called an explicitly defined sequence. But you also have recursively defined sequences. If a sequence is recursive, it means you have to actually plug a previous term value in to get the next term. Recursion almost never comes up this entire unit. I know. I would say 99% of what we do will be explicitly defined. There are a few homework problems tonight with recursion, but that's all that I've seen, and I've done the first however many, 10, 12, I've done at least 12 lessons, right, so far out of the 15 or whatever that there are. So no recursion so far, apart from that. All right. So, what I want you guys to do, let me erase this, is take a minute and I want you to find the first 5 terms of each sequence and then find the limit, if you can, as n approaches infinity. So the first sequence is this explicit or recursive? Explicit. This is explicit. What about this one? Recursive. Be careful with this one. We have the first term, so the next term we need would be the second term, but in order to get the second term, you actually plug a k value in of 1 to get a sub 2. Does that make sense? So the first value of k you're plugging in is 1 so that you can get a sub 2. All right, so take a minute, work with your partners, and see if you can figure out the first 5 terms of each of these. And then take it up a notch and see if you can find the limit as n approaches infinity.
Ooh, fancy.
Once you find the first 5 terms of the first sequence, double check with your partner and see if you guys match.
Because no matter what you want, add 2.
Well, it's because it's like competitive.
You're on the right track.
Cycles like It's just 2n over n.
And then as n goes to infinity.
So, could you L'Hopital it?
2 over 1, which is 2. But you didn't even know it. Actually, I did it in the way we were.
You could do horizontal asymptotes.
Exactly.
Same degree top and bottom, quotient and leading coefficients.
Ooh. Will Paul did it that way. I thought it was a Will Paul.
Are you okay to see number 1?
Sure.
Check your answers. the right limit?
Yeah.
The limits work the same as if you were taking the limit of the function, right? So you can either L'Hopital, or for this one, you can say, oh, same degree top and bottom, so it's 2 over 1, which is 2. Right? Is that good? All right, so have you guys found the first 5 terms yet of the second sequence?
Yeah.
No?
Yeah.
Take a minute. See if you can do
I
it.
just got 1 equal to infinity.
It's just an inputter, but it's not really n, it's not really a term, that's why they use k instead of n. You're trying to get a sub 2, so you would plug in a 1 for k, so that you get a sub 2. Does that make sense? That's times whatever you plug in 1. I'll give you a start. In order to find a sub 2, so to find a sub 2 means that k has to equal 1. So we get a sub 2 equals 1 plus 1 over 2 times a sub 1.
Why don't they just do a of k equals k over 2 times a of k minus 1?
Oh, you know, there's so many ways to approach these, right?
Or you could do a of k minus 1 equals k minus 1 over 2 times a of
You
k
could
minus 2.
sure do that. You could rewrite this if you wanted to, with a k and then a k minus 1 and a k minus 1. And then you could plug in a 2 when you want the second term.
Exactly.
It'd be the same thing numerically.
Well, I was just ignoring the k minus 1. I was reading it the other way.
So for this one, whoa, the second term's the same as the first. Is that allowed?
Yeah.
Yeah.
Because 1,
No.
1, 2, 3,
That was Will Paul saying no, being wrong.
21,
Jared.
44,
It's Jared.
65, 109, 700.
That is a good question for this one. Why does the k have to equal 1? Well, because we have a sub 1, so the next term we need would be a sub 2. And how do we get a sub 2? Well, we need a 2 here. So k plus 1 has to equal 2, so we need k equal 1. Yep. So for the next one, we want a sub 3, so k would have to be 2. Well, but then what about that guy? Yeah, if you think of it that way, yes. Yeah. The other thing, and guys, I don't know if you heard what Hannah said, if you don't like thinking of it as an individual k value like that, you can think of it like this. You could say a sub 2, right? So the next term is equal to that 2 over 2. Just think of this as a 2, 2 over 2, times a sub k would be the previous term, right? So 2 over 2 times the previous term. Then I want a sub 3, 3 over 2 times the previous term, right? A sub 4 would be 4 over 2 times the previous term. However you want to think about it, it's fine. As long as you get the right thing written on paper. How'd you do?
Perfect.
Any questions? There is no way to get a limit analytically from a recursive sequence. You really just have to look at the numbers, right? And see what they're approaching, or create an explicitly defined sequence based on the numbers, right? But you can look at these, think about it, and know that they'll always be getting bigger, so they're going to approach infinity. Yes?
Would you be able to say if infinity equals infinity, or do you have to have some limit?
You need the limit.
Oh, that's right.
You need the limit. Okay. All right. Finding limits with sequences is the same as finding limits with functions. You can use L'Hopital if you get a 0 over 0 or an infinity over infinity. Here's the big thing. A sequence is convergent if the limit exists. A sequence is divergent if the limit does not exist. These are big vocab words that you really need to know. So, really know these, okay? Okay, convergent, this is for sequences, not series, sequences. If the limit exists, it's convergent. If the limit does not exist, it's divergent. This has nothing to do with the movie.
How would I kind of go.
Okay, or book.
Wait, how would a limit not exist?
Like the last one that approached infinity.
Okay, that means it
By the way, when we say the limit of a sequence, we're talking about the limit as n approaches infinity. So if people just say, hey, what's the limit of the sequence, they really mean the limit as n approaches infinity.
Okay. Or A.
Alright. Anyone need another minute with this?
Yeah.
Alright.
Okay. Okay, so just for fun, I want you to see if you can find the limits of the following 4 sequences, and then based on your answer, tell me if it's convergent or divergent. So take a minute, find all 4 limits, and then determine if the sequence converges or diverges.
Because it's infinity over infinity.
The first 2 are convergent, right?
Yep. There we go.
Yes.
No, if you're not less hospital.
Sorry when I'm watching, I know. It's hard for me to grade when it's so much. Make sure this one, that you make sure it's negative, because it's 1 over negative 2.
Can you have 0 times 0?
That happens.
No, I think 0 times
That's okay, yeah, that's leave it, because like you.
0 is still a number.
Wait.
0 is fine.
So if you have the L'Hopital, does that make it divergent?
Nope.
Okay. So they're all convergent.
To me, they were.
There's your first. If it, check your answer, is that okay? I think everyone I saw got
Limit
that.
of ln of x.
How do you find the limit of convergence?
Did you guys get the second one?
Yeah.
Tell. Did you get 0? Fantastic. Third one. Does third one work with L'Hopital?
No.
It doesn't. This is one of those fun ones where if you L'Hopital, it's just going to flip back and forth, right? Do you guys remember these problems? Okay, you get that circular thing. So how do you approach limits as n approaches infinity of these types of functions?
Get rid of the constants in the box.
Beautiful. Okay, so what happens is when n is approaching infinity, all the terms that are non-leading terms are completely irrelevant. Because think about it, you have infinity squared plus 4, right? Does the 4 really matter? Okay,
It's a little rude.
so, okay,
I mean, how would you like to be that 4?
So
Sitting
you-
next to infinity?
so you have 5n over the square root of n squared, and 5n over root n squared is really just 5n over n, so this limit is 5. Here's the other happy thing, right? Sequences and series, your input are always, they always start with 1, and they're always the positive integers. So we're always approaching positive infinity. You never have to worry about square root of n squared being negative n for these, because it's always 2 positive, which is nice. All right, last one. Dun, dun, dun. Cosine of 2 over n, what does 2 over n equal?
0.
It equals 0. What's cosine of 0? 1. They all converge, look at that.
Oh, what did you? Oh, I took the derivative.
Whoops.
Love you guys credit.
Okay.
It's okay.
Good. Now, these are fun and challenging and all different. So, when you are given a set of numbers and you have to find an explicit rule, sometimes it's easy and sometimes it's not so easy. I'm going to give you a few helpful hints, all right? Do you guys remember in the past, I know you studied arithmetic and geometric sequences, right?
No. That was the worst. Nope.
Okay, so an arithmetic sequence is a sequence where you add to get from one term to the next, right?
Yeah.
Whatever you're adding is called your common difference. Essentially, that is your slope. That number goes in front of your n. So if I have enough, say I have a sequence, let's just pretend, I have the sequence 5, 7, 9, 11, dot, 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 right? Then I know that my sequence, my rule, is going to be a 2n because I'm going by 2 every time, right? Now, how do I get to start with 5? Well, if I plug in a 1, I get 2, so I have to add another 3 in order to get to that first term, right? And then after that, think about it, plug in a 2, you get 7, plug in a 3, you get 9, plug in a 4, you get 11. So the number that you're adding to get from one term to the next, that's like your slope, right? And then whatever you need to add to this to get, or subtract, to get to that first term, that's what you put on the end there. That's for arithmetic sequences. And sometimes you can look at just the tops and just the bottoms and think of them as like two separate arithmetic sequences, right? So you can have one sequence for the numerator and a sequence for the denominator. Or you could look at the whole numbers and think of it as an arithmetic sequence. What was your question? Did you have a question? That's how you hand it.
No, we'll just keep going.
Okay. Come on. There you go. Suppose you have something where you're multiplying every time, right? So say instead of going 5, 7, 9, whatever, say I went 5, 25, oh, let's start with 5 and do it times a different number. Like 5, 15, 45, 135, dot, 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 right? So now I'm not adding, I'm multiplying by some number to get from one term to the next. This is a geometric sequence, right? When it's geometric, the number you're multiplying by, that's the number that's going to the n power. Because I get, this would be 5 times 3 to the first, 5 times 3 to the second, 5 times 3 to the third, right? So that number, that's called a common ratio, right? It's raised to the nth power. And then whatever I need to do in order to get that first term, so this one we'd have to start with an n equals 0 though, so we'd have to switch it around.
Can you just think of one as one?
Yeah. Like that.
So it has to be an n over n.
Yep. So, yeah, sometimes it's a little tricky and you have to finagle a little bit. But anyway, so when you're multiplying, that's your ratio goes in there. You might have to play a little bit with the leading coefficient and the exponent. Last thing I want to tell you before I set you free on working on these, if the numbers alternate in sign, right, positive, negative, positive, negative, positive, negative, right, positive, negative, then you know somewhere in your formula has to be a -1 to the n. Because when -1 is raised to an even exponent, it's positive. When -1 is to an odd exponent, it's negative, right? So -1 to the n, if you start with a negative, -1 to the n plus 1 or n minus 1, if you start with a positive. Okay, so figure out, see how many of these you can get. Work together. See how many you can get. Wow, this is a nice case too. Oh, sure, go ahead.
Can you do recursive rules?
No. Explicit. Because you're not going to be able to find the limit with recursive.
Oh dear.
Oh no, wait, one may or may not be recursed like that.
Yeah.
Well, it'll be negative 1 p.m.
Yep.
I'm going to think I'm not a good.
It's alright, Jared.
Yeah, for several of these, there's more than one way to write it. That's okay.
You're taking natural, I go negative numbers.
Yeah, to 12. If you did your convert site first, just
Oh, we got two.
4 9s and
We had a chance of finishing.
Number 1 is easier if you put the negative with the top number, that very first negative, and think of it as negative 1 over 3.
Yeah, I didn't see that either.
Wow.
Yeah.
That's so much.
Yeah. Be careful because a lot of these are different numbers that have been reduced. So, like 1 might have been, who knows, 9 over 9, it might not, right? You never know. But just remember that sometimes the terms like 2/3, ooh, we're going 3, 6, 3, 12, 15. What if we wanted this to be 3, 6, 9, 12, 15? Maybe this was 6 over 9. Right?
You're adding 1 to the bottom.
Yes, you're adding 9 there. Five, 11.
Negative 2 plus 1 minus 3.
Believe it or not, 5 is actually just a simple geometric sequence.
So what's at the bottom?
All right, the hint I just gave over here, which I'll tell the whole room, is 5 is just a straight up geometric sequence.
Oh, okay.
Four was the hardest one.
Yeah, boys really are.
The denominator's easy, it's the numerator that's tricky.
That one is minus and then plus.
Oh, no, it works.
Because we're adding.
That's how you get
I did it as a separate topic. How do I do No, you always start with, I always start with slow at the end. So where you add
Wait.
So I always start with 2 n. And then say, all right, now. And then I always just kind of double check like
One. That's right. Nope, no, it's like this. It's like this.
Oh my gosh.
I mean, I know that that's.
Okay, cool, I still have it.
Tommy, that's right, we got it wrong.
Tommy forgot.
I guess it's 1 to the negative.
Oh, let's hear it.
I'm not showing you the answers yet, I'm just
4
gonna
ninths
put
is
a little,
times 3 halves.
thing up.
We wouldn't have known before, okay.
4 ninths is the first term, and then you multiply by 3 halves to the n minus 1.
I don't know.
Oh, that makes sense.
Yeah. Because like if you take 4 ninths and multiply by 3 halves, you get
That's
the
the,
2
he
thirds.
just, he
And
just
then you multiply
like.
that by 3 halves, you get 1.
Hey guys,
Very good. Good, and that's 3 to the n? Okay, make sure the negative is in parentheses, like that it's negative 3 to the n, not negative 3 to the n. Because if it was negative 3 to the n, then all of them would be negative. And you want the negative to flip flop, right? Negative positive, negative positive.
No.
The limit is 2, right?
Okay, yeah. Negative positive, negative positive. So you need it as actually negative.
Oh my heavens.
Like that. And that way it's the negative.
Or you're adding it.
So the numerator is
For the first one, since we're adding 2 each time, we know it's gonna be a 2n, right? And then if we plug in a 1, we need to get a negative 1, so we need to do 2n minus 3 in order to get the top to work. For the bottom, since we're adding 1 each time, we know it's just gonna be an n. And if we plug in a 1, we have to add 2 to get that first term. So we're gonna have a 2n minus 3 over an n plus 2. And if you actually do your limit, which I don't know if any of you have remembered to do the limits on these, but if you do the limit, this converges to 2.
Oh, we're supposed to.
Yeah. Do you guys get number 2?
Negative 1/3 to the n.
Negative 1/3 to the n. Very good. So you could write as negative 1 to the n over 3 to the n. Just know that that's the same thing as negative 1/3 to the n. It's also the same as 1 over negative 3 to the n, right? All of those are equivalent. This we haven't really talked about yet. In order to do this one, you would have to do one of those funky L'Hopitals, but just know this converges to 0 and we'll learn why later.
Not sure why.
Yeah. So, oh, I showed you the answer. Do you guys know what this one is?
Yeah.
What is it?
Negative
1
1
to
to
the
the end.
n times.
Negative times negative 1 to the n.
Okay, you could do negative times negative 1 to the n. I did negative 1 to the n minus 1. You could do negative 1 to the n plus 1, right? You could do negative 1 to the n plus 27, if you want,
N
right?
plus infinity minus 1.
Oh, no. Okay, since this one, if you just look at the numbers, is this ever going to converge to a single y value?
No.
No, so this one diverges, right? All right, 4 is the toughest. The bottom increases by 3s, right? But the top one is tricky. It's a squared, right? It's a squared. This is n squared minus 3 over 3n. So the top is tricky. If you do the limit, you're going to get infinity squared over infinity. If you L'Hopital, you get infinity, right? So this one diverges. And we get the last one.
4 ninths times 3 halves to the n minus 1.
Wow, Brian, way to
Beautiful.
copy.
Very nicely done.
Wow.
Very nicely done. So 4 ninths times 3 halves to the n minus 1 is exactly what I got as well. And this one also diverges. We'll talk about why later on. Do you guys remember, we'll talk about why later on because we only have 2 minutes. All right, good. Any questions? Yes. Sure. So number 5, you're actually multiplying times 3 halves every time. And it's hard to see, but you are. So that's how you get your common ratio. You want that 4 ninths out front, but then you want it to be 4 ninths times 3 halves to the 0, so that you get your first term. So you do an n minus 1 so that you have a 3 over the 0 to get that first term. Does that make sense? All right. I don't know. That's all I can say. I don't know how heavily this will weigh on your test for this unit. My guess is a little tiny bit, if at all.
Why can't this be our entire test?
Anyway, we'll see. I haven't seen the test yet. I can't say. All right. So we have a few minutes, and I want to take a few minutes, do a quick review problem. This is a fun one. We have time, there's always time for review.
Wait, do we get our new, our homework?
Oh, yes, okay. Thank you for asking.
You're welcome.
So,
Come on. Tell me
This
that.
Friday,
You could've
you
gotten
always
away
spend
with it
homework.
too.
I know, but it would probably be online anyways.
Yeah,
Yes,
at least you tell us that you're
It's
supposed
a
to.
nice teacher.
And I have no idea.
Tommy is.
I'm not one kid. Hey,